All right, hi everybody. Welcome back to this channel. Thank you very much for joining me once again. If you're new to this channel, guys, please just make sure you have subscribed. Just turn on that notification bell so that you can be notified every time that I upload a new session. Okay, let's look at this quite interesting question. Today we're going to be looking at counting and it's part of your counting principle. And we just want to explore a letter arrangement, right? How many different words can we form using the letters of a certain word, right? Obviously, this is also derived from your permutation, right? But we're just going to dive into that in a second. Okay, so the question says, find the number of words with or without meaning, which can be formed using all the letters of the word again. All right, so we are given the word again, and they're saying use these letters that are used in this word again to form different kinds of words. How many words can you form with or without meaning with these letters of the word again, right? The second question says, if these words are written as in a dictionary, right? In this case, order matters. And it's sort of like in alphabetical way, right? What would be the 50th word, right? Quite an interesting question. Let's start with the first one. So we have to use the letters of the word again to count how many different words can we form with or without meaning. Okay, remember from your permutation, if I have n different items, and I want to determine how many ways can I arrange them, right? How many different ways can I arrange them? This can be done in what? N factorial ways. Okay, so this can be done in n factorial ways. But what if from those n items, there are some items, let's call them R, that are repeating? Okay, uh, in the case where there are some of them that are repeating, we have to divide by the permutation of the repeating letters so that we can form different letters, right? To cancel out the effect of those repeating letters, we just basically divide by their factorial. Then it will just cancel their repetition there so that you don't count, for example, if you have G, GIN, and someone can claim that I'm starting with this GIN. You can see this is just still the same letter. It's not, you can't say that two different words there, right? Although you swap this A, you start with this, you swap. So to cancel out that effect of repeating letters so that we get different arrangement, we have to divide by the factorial of those repeating letters. Okay, so okay, let's go and count these ones. So basically what you do is you count how many letters are there to arrange. So you have 1, 2, 3, 4, 5, right? So the total number of ways in which this can be, total number of different words that can be formed with this will be what? 5 factorial. But we do recognize that the A's are repeating. Can you see? So to cancel out the effect of the repeating letters, we divide by the factorial of those repeating letters. So we're going to divide by what? By 2 factorial because A is repeating 2 times. Okay, so this will be the same as 5 factorial divided by, sorry about this, divided by 2 factorial. Okay, so you can just punch your calculator, 5 factorial divided by 2 factorial. Okay, so there are a total of what? 60 different words that can be formed with or without meaning using the letters of the word what? Again. All right, let's go to the second one. It says, if these words are written as in a dictionary, this is very important, guys. What will be the 50th word, right? What is the implication if we are writing this as in a dictionary? Okay, so if we are writing as in a dictionary, it means that you'll be writing in alphabetical order. Remember, a dictionary letters they are put in alphabetical order. All right, so we need to count what will be the 50th word. They need that 50th word. What will be the 50th word? Will it be GAAIG, what, something like that. What would be the 50th word, right? So what we can do first to say, if we are arranging in alphabetical order, obviously we have to start with A, right? A, then the following letter will be what? G, right? In alphabetical order. Then another one will be what? I think it will be I and A, B, C, D, E, F, G, H, I, J, K, L, M, H, I. Yeah, it start with I, then N. Okay, so what we're gonna do is we're gonna count all the letters of the word that start with A. Remember, these A's are just the same, right? So I can just say letters that are starting with A. So we're gonna count the words that can be formed. Starting, my pen is, sorry about this. Okay, starting with, so we're gonna start with A, right? If we are starting with A, if we start with G, if we start with I, if we start with N, what will be the letters, the number of words that can be formed? So if we are starting with A, right, A will be there. There's only one way, all right, that is put A there. Then the rest of the letters are G, AIN can be arranged anyhow, right? So you have 1, 2, 3, 4 of them. So these ones can be arranged in what? So it will be 1 times 4 factorial, because this one you have 4 items and they can be arranged in 4 factorial ways. So they're not repeating letters inside there. So it's just 4 factorial. On your calculator, 4 factorial, I think it will be something around 24 words, right? So if we start with A, all the letters that are starting with A would have only formed 24 words so far, right? But we need, what will be the 50th word? So far we have 24 words. A, starting with A, coming G, they swap everything, right? You're only gonna form 24 words. What if you start with G? If you start with G here, there's only one way, that is put G there, but the rest of the space here, if we are remaining with AAIN, right here. So if you're starting with D, it's one way there, times inside here, you have 4 words. They can be arranged in 4 factorial ways, but the A's are repeating, divided by what? 2 factorial. Okay, so this will be 4 factorial divided by 2 factorial. It's 24 divided by 2, which is basically 12, isn't it? So 12 words. 12 words. So what is happening here, guys? In a dictionary, when we're starting with A, we are reaching word 24. Plus, the next one will come and start with G. Remember, we're following alphabetical order, right? If we're starting with G, we're gonna form 12 words. There are only 12 words that can be formed, right? So far, in total, we have 24 plus 12, which is like 36 words, right? We need this 50th word. Okay, so let's move to I. Okay, let me put this a bit down. If we're starting I and N. If we're starting with I, the rest of the word, I mean, in that position, if you're starting with I, there's only one way to do so. Then we're left with GAAN, right? So these ones inside can be arranged in 1, 2, 3, 4. There are 4 of them, 4 factorial, but the A's are repeating 2 times divided by 2 factorial, which is also what? 12 words, right? So the next word in the dictionary will be I. After the 36th word, the 37th is going to be I. And I mean, the one that start with I. And those that start with I, we can form 12 of them, right? So from this 36, let's add 12. Then we have our new total now, which will be, let's say, plus 12. 48 words. Can you see we are heading somewhere? We need the 50th word. Obviously, we are sure now that the 50th word is going to start with what? With N, because 48 words, it's when you have started with A, G, and I, right? You are able to form 48 of them. But then the 50th word, you can see, we can't even bother to count here, right? Rather, we can just go and write this in alphabetical order. Okay, obviously, the 49th word will start with N, right? Start with N. And this word will be N. If we follow alphabetical order, it will be A, what? I-G or G-I. G-I. Okay, so this will be the 49th word. Then the 50th word, obviously starting with N, would be what? Will be N-A-A. Then what will happen here? We're going to just swap there and we say I-G. So this will be what? The 50th word. Okay, so basically it was a bit of a trick, but quite interesting just to look at the restriction to say if they're saying you are writing them as though it's in a dictionary, obviously you have to write them in alphabetical order. So what we did to get the 50th word, we count, okay, if we're writing alphabetical order, we're going to start with A. Then we check how many words can be formed, 24 words. The next letter that is following will be G, right? According to the letters of the word again. With G, we check how many words can be formed 12. So we have 24 plus 12, which is 36 words so far. Then the next one is going to start with I. How many words can be formed starting with I? It's 12. We add there, we realize it's 48, right? So the letters that going to start with N, if you check, N is first position, and the rest, A, I, G, these ones can be arranged in what? 4 factorial ways, divided by A's are repeating 2 times. So it's 12 words that's going to start. So if you go to 48 now and you add these all 12 words, that's going to start with N, right? Plus 12. We're going to have a total of what? Of 60 different words, as we calculated previously there. Can you see? Just to prove that our answer is correct. So 48 words are those ones that, addition of those ones that going to start with A, G, and I. Then when you go to the 49th word, it's going to have to start with N, right? Because the next one, according to alphabetical order, should be N. So if you're starting with N, then you realize there are 12 words that start with N. So we are checking which one will be the 50th word. So 49, we just write in alphabetical order. N, what's going to follow? A-A-G-I, according to alphabetical order. Then the next one, N-A-A, we just swap the to get a different word. Then this will be our 50th word. Okay, I hope you find this session helpful, guys. Don't forget to subscribe, like, share, and comment. And let me hear what you think about this lesson. Thank you very much. See you soon. Bye.